In this video, we will do an example involving a rotating camera. So it says that a camera situated 3 kilometers from the location of a rocket launch records the rocket after it takes off. If the camera is rotating upwards at a rate of 1/120 radians per second, when its angle of elevation is 45 degrees, how fast is the rocket traveling at this instant? Okay, so let's get this started by drawing a picture. Okay, so we can draw the ground. All right, and somewhere on the ground we have a camera. Okay, so I'm just going to draw like a rectangular box to represent the camera. And then it says that the camera is situated 3 kilometers from the location of a rocket launch. So let me just draw a dot to indicate where that rocket launch is. And okay, so after some amount of time, it says the rocket takes off, and then as it takes off, the camera is sort of tracking the rocket. All right, so I'm going to draw the rocket somewhere in the air. All right, so the rocket, maybe something like this. All right, so the rocket is moving upwards. All right, and as we do that, it talks about something called the angle of elevation. So if I form a straight line from where the camera is up to the, let's say, the top of the rocket, I'm just going to think of the rocket as being a point. Okay. What we get is this angle here. So the angle from the horizontal up to this straight line, that is called the angle of elevation. All right. So we have this. Now let's label variables and quantities that we know. So one thing that we know is we know this distance is 3 from the camera to that launch site. I don't need a variable for that because that's constant. That's just 3. This angle is changing because as the rocket climbs, that angle gets bigger. So I'm going to assign a variable like theta to it. Another thing that's changing is the height of the rocket. Let me call that h. So the height of the rocket, and it might be helpful to draw kind of a vertical line straight down because that forms a nice right triangle. Okay, so now let's write down the rates that we know and the rate that we want to find. All right, so this question tells us that the camera's rotating upwards at a certain rate. So that's the rate at which the angle is changing. So d theta dt is, and that angle is going to be getting bigger as we said before. So this is going to be positive 1/120. And it asked me to find how fast the rocket is traveling. So that's going to be dh dt. dh dt at this specific instant when this angle is 45 degrees. So I'm going to write that in radians. That's pi/4. All right, so now let's set up our equation. Okay, so we need an equation that's going to involve theta and that's going to involve h. It might be tempting to say, Pythagorean theorem, but because I have a right triangle, but with Pythagorean theorem, I don't get to use theta. And it involves the hypotenuse, which I don't really have information about, and I don't really care about the hypotenuse. So instead, I'm going to use trig. And if I use tangent of theta, that involves the two sides I care about and that I have information about. So tangent of theta is h/3. Now let's take ddt of both sides. So ddt of both sides. So ddt of tangent of theta on the left, and ddt, let me rewrite this as 1/3 h, so I don't have to do quotient rule. So now I differentiate implicitly. Derivative of tangent of theta, I start off with the derivative of the outside thing, the tangent, and then secant squared. So we get secant squared theta, but then we do chain rule and multiply by the derivative of the inside of the theta, and that's d theta dt. And on the right, the 1/3 is going to stay multiplying the derivative of h, which is dh dt. All right, so now let's plug in our values. So we'll get secant squared, and now I'm going to plug in that theta is pi/4 times d theta dt, which is 1/120. And on the other side, that equals 1/3 times dh dt, and dh dt is unknown. dh dt. Okay, so if we work out secant of pi/4, maybe using unit circle, turns out secant of pi/4 is √2. So secant squared means, well, take that value and square it. So we'll have that times 1 over 20, sorry, 1 over 120. And maybe it would be helpful if I also just multiply both sides by 3 to cancel that 1/3. So I'm going to put a 3 up here at the top of this fraction. So that'll be equal to dh dt. All right, so we're almost there. Root 2 squared is 2. And then 3 over 120 simplifies to 1 over 40. 1 over 40 equals dh dt. So if I simplify, we get dh dt equals, I can cancel a 2 and be left with 1 over 20. So the units are going to be the units of h on top. And let's see, the units of length in this problem were kilometers. Okay, so on the top I'll have kilometers. And on the bottom I'll have units of time. And units of time in this question are seconds. So I'll have that over seconds. And that is my answer. That is how fast the rocket is traveling.